Welcome to Bridge Mathematics 1, Module 7, Topic 3, Measures of Variability.
What is standard deviation? Standard deviation shows how much variation there is from the mean. It is calculated from the mean only. If standard deviation is low, it means that the data is close to the mean, while high standard deviation indicates that the data is spread out over a large range of values. The standard deviation is always positive or zero. It may serve as a measure of uncertainty. If you want to test a theory or want to decide whether measurements agree with a theoretical prediction, the standard deviation can provide that information. If the difference between the mean and the standard deviation is very large, then the theory being tested probably needs to be revised. The mean with the smaller standard deviation is more reliable than the mean with a large standard deviation. A smaller standard deviation implies the homogeneity of the data. When can you use standard deviation? Standard deviation is used when one requires a more reliable and accurate measure of variability. It also needed when further statistics like correlation, regression, test of significance, and others have to be computed. Here are a few real-life scenarios where standard deviation analysis is used. Assessing risk. In finance, standard deviation is used to measure the volatility or risk associated with an investment. Higher standard deviation implies greater variability in returns, indicating higher risk. Quality control. In manufacturing and quality assurance, standard deviation helps to assess the consistency and uniformity of products by measuring the variation of a process or product characteristic. Data analysis. Standard deviation helps in comparing datasets by providing a standardized measure of variability, allowing for meaningful comparisons between groups or populations. Inferential statistics. It plays a crucial role in hypothesis testing and confidence interval estimation. For instance, it helps determine the margin of error in sample surveys and assess whether observed differences between groups are statistically significant. Why do we use standard deviation? In statistics, the standard deviation is the most common measure of statistical dispersion. In addition to expressing the variability of a population, standard deviation is commonly used to measure confidence in statistical conclusions. For example, the margin of error in polling data is determined by calculating the expected standard deviation in the results, if the poll were to be conducted multiple times. The standard deviation is simply the square root of the variance. This is useful and interpretable statistic because taking the square root of the variance puts the standard deviation back into the original units of the measure we used. Recall that the variance is the average squared difference. When reporting descriptive statistics in a study, if researchers report a mean, they virtually always report the corresponding standard deviation. When compared to the range, the standard deviation is a much more robust measure of variability. Robust is a term used by statisticians to mean resilient or resistant to outliers. Standard deviation is therefore the most commonly used measure of variability. But standard deviation as a measurement of variability also has its drawbacks. While calculating standard deviation, the more weight is given to extreme values and less to those near the means. Large deviations when squared are proportionally more than small deviations. This is why it is recommended only when the distribution is normal or near to normal. How do you calculate standard deviation? This is the formula for population standard deviation. To calculate for population standard deviation, follow these steps. Step 1. Find the population variance. Recall that the steps to find population variance are these. From the dataset, get the mean. For each data point in the dataset, subtract the mean, and then square the difference. Add all the squared difference for all data points. Then, divide the sum by total population of the dataset. Step 2. Find the square root of the population variance. Next is the formula for sample standard deviation. To calculate for the sample standard deviation, follow these steps. Step 1. Find the sample variance. Recall that the steps to find sample variance are these. From the dataset, get the mean. For each data point in the dataset, subtract the mean. Then, square the difference. Add all the square difference for all data points. Divide the sum by the number of the samples minus 1. Step 2. Find the square root of the sample variance. How is it? Did you get all of it? How about we try some practice problems to sharpen your skills? Let's go!